Hey guys, welcome back. Now, it says, communicate precisely. A 3D printer, Emery, makes the chocolate mold shown by copying different shapes. Which of the designs in the mold appear to be congruent? So let's see. All right, so A and C kind of look congruent, right? G also looks like it could be congruent. So A, G, and C look congruent. And they just said look, appear to be. So I can kind of go just by looks like here. All right, and then let's see, who's congruent with B? It looks like B is just a 45 rotation of D, so B and D. C, we already covered, so C and D, we already covered. E, okay, so who's congruent with E? It looks like E and F are congruent. And H and I, ooh, we forgot I. So it looks like B, D, and I are congruent. I put a pi symbol there, not a congruent symbol. What am I thinking? All right, and I think that's everything. Then it says, describe the composition of rigid motion that maps the congruent shapes onto one another. Okay, now again, there's more than one answer, but to get from A to C, it looks like you could just reflect, flip it over, right? To get from A to G, it looks like you could rotate it here, spin this around so that you're upside down now. So it's totally upside down. So that's probably a rotation of 180 degrees. And again, that would be the same whether you go clockwise or counterclockwise. All right, so we got the first one. Now, how do we do some rigid motions for B and D? So if I go B and D, yeah, it's if I rotate it 45. So B to D, if I rotate 45 degrees, not a full 90, 45 degrees counterclockwise, excuse me, then it would map upon itself. Now, obviously, there's also and then translate to scoot it over there. So there's and translate to scoot it over there. Same with this one. I'd have to rotate 180 and translate to scoot it over there. Now, D to I, to get from D to I would just have to translate because they're already in the same orientation. So I'd have to translate to the right and then down. Okay, now let's talk about E to F. Yeah, same thing. E to F, their orientation is the same. So all you have to do is translate over to the right. Nice. Let's look at 19. It says, all are the illustrations of the shoes in the advertisement congruent? If so, describe a composition of rigid motions that map the left shoe on top of the right shoe. So it looks like at least the pattern would be to reflect over a vertical line. Now, what's interesting is if you reflect over a vertical line, it was an actual shoe, then it would be the underside of the shoe, but we really just mean the image. Okay, let's take a look at 20. It says, describe the rigid motion or a composition of rigid motions that can be used to make sure that each slice of Keese is exactly the same size. So let's figure out how many lines of symmetry this piece, how many pieces of pie? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know that this central angle is 360. So we're going to take 360, divide by 8 to figure out what angle of rotation is needed here. So 360 divided by 8 is 45 degrees. Cool, so if you rotate pi 1 45 degrees, you'll land on pi piece number 2. So we can write any rotations of a factor of 45 degrees will map each piece of quiche. It's like a cheese, egg, pie type of thing. Each piece of quiche upon itself. To confirm, all pieces are the same size and same shape. Nice. Okay. So 21 and 22. The transformation, so we got to do this one first. This is rotate, right? 90 degrees about point A, rotate. And then this is translate, 3 to the right and 8 up, because those are positive. So the transformation given here maps ABC to DEF. Is ABC congruent to DEF? The answer is absolutely yes. Since translate and rotate are both rigid motions. Therefore, the size and shape would stay the same. What kind of transformation is that? A congruence. Oh, I get to use that word we learned today. A congruence transformation. When I use a series of transformations and they remain congruent. Nice. Okay, last question. Pretty easy homework today. Which board game token is shown? So if I flip this upside down, or right side up, this is in the top left, and this is in the bottom right. And so if I flip my paper upside down, the problem with C is now the plus sign, if it's upside down, is the plus sign's in the top right. So I kind of need to look at it 90 degrees to the right. If I turn, or excuse me, the left. If I turn my head to the left, 90 degrees, this is now in the top left, right? And this is in the bottom right. And so that's why I'm going to pick C. But again, my head, I have to turn my head. If this is my head looking, here I am, right? Looking at my shape, right? Here, I'm looking at my shape. I'm going to cross this one out. Now I'm looking at my shape here. All right, and from these orientations, they look the same. All right, thanks guys for joining us. Have a great day.